Alright, hi guys, it's our time again. Welcome to Teacher Susan Exploding Chemistry. Today we are going to do thermochemistry under heat of neutralization. What is the general definition for heat of neutralization? It is heat change when 1 mole of water is formed from the neutralization between acid and alkali solution. Now before that, let's watch a movie. In this demonstration to determine the heat of neutralization, they are using hydrochloric acid and also sodium hydroxide solution, and we are using polystyrene cup because it is a better heat insulator. Well, what he is doing now, he will measure 50 cm cube of hydrochloric acid and pour it in one of the polystyrene cup. Then now he is measuring another 50 cm cube of sodium hydroxide solution by using a plastic measuring cylinder. And please be careful, do not do this because it may cause contamination. Right now, pour this 50 cm cube of sodium hydroxide solution into another polystyrene cup. So what he is doing now, he is measuring the initial temperature of the acid. Rinse and clean the thermometer so that he can measure initial temperature of another solution, which is the sodium hydroxide solution. He is measuring again the acid so that they can make sure that the initial temperature will be almost equivalent. So it is okay that if we don't get equivalent, we can still calculate for the average initial temperature. Now immediately pour the sodium hydroxide solution into the acid. Insert the thermometer. Keep stirring the mixture solution with a plastic cover on it to prevent heat loss to the environment, and record what is the final thermometer reading achieved. In this determination for heat of neutralization, we have a few different packages that we can do. We can combine the strong acid with strong alkali, strong acid with weak acid with strong alkali, or weak acid with weak alkali. Here are some examples of different strength of acid and alkali solution that we normally use in SPM. Before we start doing, let's practice how to balance some chemical equation for the following neutralization. Teacher is waiting for your answers. When you are given difficult and challenging question, no worry. The angel teacher Susan will always be there helping you. Here are the answers for you to do your checking. By just balancing a chemical equations, it doesn't seem fun. Now, let's try to do a real challenging question involving the calculation for the heat of neutralization. Here you go. Enjoy the challenge. Ting, ting, ting. It's time again. Your angel teacher Susan's coming to give you your solution for the balanced chemical equation and the ionic equation. After we have done the equation, step 1, we are going to calculate the number of mole for the hydrogen ion in the sulphuric acid. Through the calculation, because sulphuric acid is a diprotic acid, therefore we are getting 0.2 mole of hydrogen ion and 0.2 mole of hydroxide ion from the sodium hydroxide solution. Next, we shall calculate the average initial temperature for both acid and alkali before we proceed on to calculate the temperature change, which is a data. So the data that we can obtain here is 27 degrees Celsius. Next step that students should do will calculate the heat change. Formula-wise, Q equals to MC theta. So the M that we are getting here will be the total volume of the solution, which is 100 ml from the acid and another 100 ml from the solution. So after we multiply, we will get 22.68 kilojoule. Oh yeah, just for the reminder, normally when we apply the formula Q equals to MC theta, the final answer is always in joule. But to prevent careless mistake happening during the calculation for delta H, my encouragement for you all will convert the joule into kilojoule straight away. Now coming up next, is the calculation for the number of mole for water. According to our balanced chemical equation, the number of mole for hydrogen ion and the number of mole for hydroxide ion are both 0.2. Therefore, the maximum number of mole for water that produced in this experiment will be 0.2 mole as well. Lastly, to get our heat of neutralization, we just need to divide the heat change with the number of mole, and therefore we get negative 113.4 kilojoule per mole. And the symbol negative here represents heat of neutralization is actually an exothermic reaction. Now what you can see on your screen here is the energy level diagram. Remember to check your answer, it must have a correct profile. Fill up the energy content for your reactants and product as well as the delta H for you to get full marks. Well, we have done all the calculation, but it is not the end yet. I have a big problem. I need you guys to help me. I think until my brain is all out. What's wrong with that? Why, when I search the information, it says that the heat of neutralization between sulphuric acid and sodium hydroxide solution is negative 114 kilojoule per mole. But throughout our calculation, we are not able to get that value. Is that anything goes wrong? Can you all please help me to solve this problem? Thank you for some of the feedback to me. Actually, there are some problems that cause heat loss to the environment. Alright, sometimes students may not observe the maximum rise of the thermometer reading properly, or there might be environmental factors like on the aircon, the fan when the experiment is going on, and even parallax error while taking the measurement. Now I feel better. I thought I did a big mistake in calculating the value. Thank you for your help. Wait. Not the end yet. I found another problem here. See, hydrochloric acid and ethanoic acid, both of them are monoprotic acid. They should have the same concentration of hydrogen ion. Why? The delta H for them are not the same. Why do they have slight difference? Can someone help me and find out the solution for it? Thank you for your solution. Actually, this ethanoic acid is a weak acid. So this weak acid will ionize partially in water only. to form lower concentration of hydrogen ion. Some of the ethanoic acid still remain as molecule, refuse to ionize. Therefore, some heat will be absorbed back to force them to do the ionization so that all the hydrogen ion will be released out. That's why the delta H will be slightly lower than usual. Thank you for your solution. Well, finally this is the end of the sharing. Okay, after all, you guys helped me to solve a lot of challenge, helping me to get a lot of solution for the problem that I encounter. And now it's time for me to say thank you for your attention, thank you for your participation. Remember, give me a like, share my video, give me some comment, and don't forget to subscribe my YouTube channel. See you soon. Bye.